Hello, let's place dominoes. It's time for pips. Let's start with the easy puzzle. Right, okay, what do we have? We need 4 of something. We have 4 threes, and we have a greater than 3 that must connect to the 3. So it looks like the 3 sixes will be down there. So I guess that means the 4 goes in the greater than 3. And then we need something else irrelevant that points down into the other 3, so that'll be a 2. Which means our double 3 goes here, our double 6 goes here, and our last 6 goes here. And that was the easy puzzle. All right, we'll move on to medium. Okay, what do we do here? We need 3 of something. That could be 0 or 5. Which of those do I think is more likely? Well, okay, let's see. So we need... No, we don't need a double, actually, necessarily. Oh, this is interesting. We have 3 zeros or 3 fives, and we have exactly 3 of each of them, which means this 0, 5 goes here no matter what, but it might go in one of 2 orientations. That's kind of intriguing. I guess I'll leave that there. Just, I mean, it could be the other way around, but I'm just remembering that it goes in the grid in that place generally, regardless of orientation. We have a greater than 3 that points into a 9. So it couldn't be, for instance, this 5. Well, it couldn't be that anyway, because the... No, never mind. We don't know that the 5 is what's in the 3. But anyway, it's not that. It could be... It couldn't be the 4 pointing in. So it's actually... Here's another case where we know exactly which domino it's going to be. We just don't know the orientation. So again, actually, that is interesting. Because now we've used 2 5s, which means this one can't be the 3 5s, because we've used one of the 5s already, regardless of which orientation it goes. So that does mean this needs to be 0. So this one over here is actually in the correct orientation. So now we have more zeros. So in terms of the 0 that points up into the 9, it can't be the 3 because we don't have a 6. So, oh no, I've done something wrong. I've made a bad assumption, because now we can't make this 9 work. What have I done wrong there? Greater than 3. And it needs to be a 9 up there. What is... Oh no. Wait, this goes here. No, wait, how do we make the 9 work? Sorry, I've done something wrong and I don't understand what it is because I'm being an idiot. Okay, let's see. The equivalence region. Sorry about this. If I'm sure it's very overwhelmingly obvious to many of you what I'm doing wrong here. So, what do we have 3 of? 5s or zeros? I don't see any other possibilities. Oh, sorry. Why did I think that? Sorry, this was idiotic. I started with a completely meaningless thing. I said it's got to be the 5 or the 0. That's not true at all. That's completely ridiculous. Why would I have said that? Sorry, I don't know what I was doing. I think the other thing I said was correct. Sorry, what on earth was I doing? That was so bizarre. What a strange thing to have declared. The other thing I think is correct, that in terms of the greater than 3, it does need to be this domino, which means we're already using a 5, which means the 5s can't fit in the 3 region. That, the 3 equivalents, that part is correct. This other thing was ridiculous. That was totally wrong. I still don't know which direction this goes, but the point is this needs to be zeros. That is correct, which means we need a 0, 5 pointing into the 9, because that is the only one that's big enough to make the 9. So now we need 4 coming out of that, which has to be this one. No, I've done a wrong thing again. Oh my goodness. Sorry, this day is a catastrophe. Oh, no, sorry. It could also be the 0, 4. Sorry. I just didn't see that other possibility. Which means the 5 goes here, and then a 3 comes down. Okay. This is a terrible day in terms of my ability to solve a puzzle. So 5 goes across here, and then this goes here. That was the medium. Yikes. I mean, that was my, I'm not, I mean, the medium and my ability to solve it was poor. That's what I'm saying, which doesn't bode well for the hard. Let's try it and see how it goes. That was ridiculous. Oh no. Okay, well, all right. Well, we can put double six in the 18 at least right away because it needs three sixes. Um, Look at all those zeros. And I don't think we have a double zero. That's useful. We don't have a double zero, which means, are there four zeros only? There are only four zeros. Okay, and they connect to 1, 2, 3, and 4. Okay, well we need a less than 2, so that'll be the 1. And now we need a less than 3, so that'll be the 2. Okay, at least this isn't totally impenetrable starting out. So what else do we have? We have it connected to a. Okay, well the 10 can't be connected to the 3 because then we'd need a 7, which we don't have. Oh, although actually it doesn't need to go that way. It could go this way if this went up. Yeah, no, that's true. Okay. So I'm not sure which of these go where then in terms of the other zeros. Okay, what about the 12? We need 2 more sixes for that. How many sixes do we have? Is that going to be all of our sixes? No, actually it isn't. Oh no, it's not. We still have 4 sixes to place, and only 3 of them are spoken for. What about these 10s? How many 5s do we have? We have 4 5s, which is not enough to make both 10s because we also have an individual 5. Is that right? 1, 2, 3, 4. Yes. Okay, so one of the 6s will be earmarked for the 10. So all of our 6s are actually spoken for. Between the remainder of the 18, the 2-sized 10 region, and I thought there was one more. Oh, and the 12, which of course we need 2 of. So 1, 2, 3, 4. Yes, okay, that's correct. We have the proper number of those. And none of them is a double, so the 12 is connected to something else. It could be, for instance, this 5. Does that cause any... no, that doesn't cause any geometry problems or anything like that. Fine. What about this 4 down here? We don't have any zeros, which means it needs to be 4 ones. So actually, we know we can put double 1. I mean, it might be no, actually. Well, no. We should put it here because that gives us the greatest flexibility. If we put it here, then that's not possible because we would need another double 1, or same here. So it goes here. Oops. So it goes here. Okay. So that means one of them is pointing into the 10. So we only have 4 1s, so this will be the 5. So okay, so this is the 10 that has the 5s in it. The other 10 is the one with the 6. And our other, this goes here. So how many 5s do we have? 1, 2, 3. We have 3 left. One of them goes here. One of them goes into the single 5 region. I don't think we've accounted for any other 5s at this point. Okay, what about the 6s with the 12? I mean, yeah, we sort of just mused that this could go there, but that wasn't really based on anything. That was just a possibility. Okay, there isn't an enormous amount of constraint elsewhere, really. I mean, I guess the 6 region being made up of 3 cells is reasonably constrained because actually, no, it is actually, because all of our zeros are spoken for and all of our 1s are spoken for. So the 6 can only be 3 instances of 2. That's all it can be. And we have exactly 3 2s. So that's helpful. Do we have a 2 0? We don't. So it can't cross over that way. That's useful. That means this 0 points up into the 10, which is useful because it can't be the 3. So the 3 goes there. The 4 goes there. This is our other 6. Wait a second. I thought we had all of our 6s spoken for. 1 goes there. 2 go into the 12. 1 goes into the 10. Oh, no, that's correct. We have 4. Okay, I guess that's fine. So the 6 is the 2, which we need 3 of. So that's that. Okay, good. So now the other 2 connects to the 5. The other 2, I think there's only 1 left. There is only 1 left. So that points across here. And the 5 does connect to the 12. So it is that 5, 6 after all. What else is happening? We have an equivalence of size 2, which now might be meaningful. So it could be 2 3s, could be 2 4s. What about our other 6 pointing up from the 18? It's either this 6 4 connect. So no, that can't be that because we need a 2, which we don't have. So it's 6 3. So it's our other. So okay, so it's our other 3. So it is 4s connected to the equivalence region, which go down this way. And then the inequivalence, all we do is not put a 4 in there, and there we go. Okay, that took me a little longer than the medium, but it was a smoother solve in the sense that I was always at least able to figure out the next deduction. Okay, and I didn't make any completely boneheaded serialized mistakes. There we go. That was the pips. Very sorry about that medium puzzle today. Yikes. All right, back tomorrow. Bye for now.